Tech Revision with Mrs. Swanee Pooh.
Hello everyone. Today's video I'm recording in school, so apologies if there are some noisy Year 7s and Mr. Johnson's music in the background, but there we go. Today we're going to be covering the bits and bobs that you need to know about composites for the exam. So this is straight from the exam specification. So you need to know the range of composites listed on the bottom left hand side. So we've got the classic two that you think about with composites, which are carbon fibre reinforced plastic, glass reinforced plastic, quite often called fiberglass. There's some that you may not have heard very much about before, one of those being tungsten carbide, but the rest of these have been mentioned in previous exam papers. So concrete, you use that in your desk tidies with Mr. Johnson, hopefully. Also engineered wood, which is called glulam. None of these are very complicated, but we're going to go through their physical properties, why they're used. But firstly, you're actually thinking about what a composite actually is, because there is sometimes some confusion about an alloy and a composite because they are both mixtures of different materials. So a composite is a material comprised of two or more different materials. So notice it doesn't have to be a metal or a element, okay? And it results, again, similar to an alloy, in a material with enhanced properties. Now, the difference being that when you look closely at the material, it is normally still possible to see the different materials in the structure of the material. So, for example, with carbon fibre, you can see the strands of the carbon fibre going through, as well as the resin that holds it all together. Same with concrete. If you split it open, especially with something like reinforced concrete, you would see the metal beams going through. You would see the different types of stone and sand that is included in concrete. So the materials are not mixed together completely, so you can't differentiate them. You can normally see them either they've been glued together or combined together with resins to create those enhanced properties. So the first one we need to have a think about, and in the middle there you can see that the name carbon fibre has been spelt in a really American way, fibre, F-I-B-E-R. Make sure you spell it correctly as it's spelled at the top. And also remember again that when you're referencing carbon fibre, make sure you give it its full name, carbon fibre reinforced plastic. So it's expensive stuff. So this is being used for high quality products that need to have certain performance characteristics. So it's widely used to make very lightweight but extremely strong products. They usually have excellent strength to weight ratios. So it's very, very strong for its weight. It has this kind of woven sheet which you buy, and it almost pulls apart like a fabric in a way. And what you do is you create some kind of mold, almost imagine like a hollow jelly mold in a way. You put down first a release agent so that the carbon fibre will pop out of the mold once it has set, or cured is probably the correct word to use. And what you do is you put layers of epoxy resin is used in carbon fibre. And what happens is you layer it up, so carbon fibre sheet, which is flexible to get into all of the nooks and crannies of complex shaped molds. You put layers of epoxy resin, and then what happens is you either leave it just to set for smaller parts, but usually what they do is they put them in a vacuum sealed bag, and that is often put into a pressure chamber at a relatively low temperature. I mean, 170 degrees you could obviously have in your normal oven at home, but what it does, it produces pressure as well, and it's called an autoclave. So it's basically like a giant oven, but as well as heat, it also produces pressure. That causes the resin to cure, and it sets it completely rigidly in its new shape. So it is used for a range of different applications. One of the classic ones is Formula One car bodies. Airplane wings are starting to use carbon fibre a lot more. Lots of aircraft components are using carbon fibre, and some of the reasons for their use are on the next slide. This slide's a bit of a beast. It's got a lot of information on it, so you might want to pause and maybe make a few notes as we go through. But I'm going to go through just kind of the main bits highlighted in yellow. So some advantages of carbon fibre reinforced plastic: very, very lightweight, as we've obviously spoken about before. It's got really good tensile strength, so it's very difficult to stretch it or to bend it. This is a really key property of carbon fibre, and I think it comes from the epoxy resin in the material. It doesn't expand very much or contract very much in hot or cold conditions. So if you think, I know I've said this before, if it was used in a Formula One engine, a huge amount of heat is produced in those engines. And what you don't want to happen is for components to change shape, get bigger or smaller, because that could affect the performance of the car. And if you think about how much they engineer these cars to just pick up even the tiniest millisecond of improvement, if their components are changing shape and things like that, you don't want that to be happening. So it's got low thermal expansion. It stays in the same shape in heat, in hot and cold. It's got excellent durability, so really good fatigue properties. So remember, polypropylene is another one of those materials that's got good fatigue properties, so it can flex and flex and flex and not bend. It won't wear out quickly under the stress of being used constantly. It's very corrosion resistant, so it's not going to break down under chemicals or weathering or anything like that. It tends to be a really good conductor of electricity, which is one of the problems about it being used in airplane wings with lightning strike. That is a bit of an issue with carbon fibre and something that they're trying to get around. But it does have those, it does have conductivity, which can be very useful. It's UV, it can be UV resistant if you use different resins. And if you think about what type of resin has UV resistance, can you remember which one it is? It's polyester resin. So depending on which resin is used, it might give it slightly different properties. Some disadvantages to carbon fibre: it can be quite brittle. So what you'll see is if it's exposed to a really high impact, it can quite easily crack. So if you see a Formula One car crash, you'll see bits fly off, and so it can crack and break quite easily. And it's very expensive. So the cost of carbon fibre is very expensive, but it's usually used on really expensive products, and you know, they will pay that amount of money to get the properties that carbon fibre gives. You can probably hear Mr. Johnson in the background. Okay, so I'm not going to talk about this very much, but the carbon layup process, like we spoke about a minute ago, you have a mould. Mould is spelled incorrectly there. That is an American spelling of mould. So mould is M-O-U-L-D. You then have layers of resin and the carbon fibre sheet that is built up to the required thickness. And the big advantages of this way of making carbon fibre, and this is the same process used for glass fibre, reinforced plastic as well. You can make very light products because depending on how thick you make the walls of the product can change the weight of the product massively. It's very strong because of the properties of carbon fibre. More complex shapes can be made because you can make a one-off of a mould. You can make quite complicated shapes, and you can achieve a shape that would be otherwise quite difficult to manufacture. Some issues with it: it's quite labour intensive. It can be quite a complex process. If you think about larger products, you'd need a team of people working on it, and it often requires some skill and expertise to make sure that the layers are being joined together properly, and if it goes wrong, that's a huge cost implication because of the cost of carbon fibre. Some other advantages: it can be laid up in different orientations. So the fibres can be put in different directions to create strength in areas that are needed to be high strength. that sentence doesn't quite make sense, but you know what I mean. And hollow monocoque designs can be achieved. Now we're going to talk about what a monocoque design is in a second, because it's quite a useful thing to remember. And another really nice thing about carbon fibre is that you can easily add things like decals, stickers, basically, posh stickers, and then protect those under a layer of resin or lacquer during the process of making the carbon fibre. So, what is a monocoque design? A monocoque design is where the external structure of the product supports the load. So it literally means a single shell, an external frame. So rather than, for example, if you imagine that's maybe like a kayak in the middle picture on the bottom, you might traditionally need some kind of struts or supports going across there to give the product stability and rigidity. Because of the nature of these materials, composites, the glass fibre reinforced plastic and carbon fibre reinforced plastic, means that you can just make the product as a single shell. It massively reduces the weight, but you still maintain the same strength and rigidity. So this is used a lot in car chassis, in boat hulls, in airplane fuselages, and it's a massive advantage of carbon fibre and glass fibre. So if you were asked in the exam to say what is an advantage of using carbon fibre over a traditional material like steel or something like that, you can say, well, it's much easier to make monocoque designs because the material is so rigid and strong. The product, you know, is strong enough to function as just a single shell. So classic example is an egg. The strength is all in the shell. The only slight issue is that any damage to the shell is obviously going to compromise the integrity of the structure. And another slight issue with carbon fibre and glass fibre is that repairs and modifications can be quite tricky. You normally have to patch it and things like that, which can look a little bit messy. Right, next one we're going to talk about, this is kind of like the cheaper. So if you think carbon fibre is Waitrose, this is probably more like your Tesco version of a composite. This is glass fibre reinforced plastic. It's got some really good properties, but it doesn't give you that really whizzy carbon fibre kind of texture, and it doesn't have as many of the properties that carbon fibre has, which makes it suitable for those high performance products. So this is quite often used on things like boat hulls, kayak hulls, caravans, and some good things about it, it's made in exactly the same way. So you can see there's a team of people with sheets of glass fibre, and then they're painting on a polyester resin is used in this instance, because usually it's being used outdoors, so it's going to need some kind of UV resistance. So it's got really good resistance to chemicals, to weathering, any corrosion, any damage to the surface. It's high strength, it's high impact resistance, it's relatively easy to fabricate, it's lightweight, it's relatively low maintenance, and it has quite a long life cycle. So it lasts quite a long time. I think 20 years was the time that I saw you would expect a glass fibre reinforced plastic product to last. And one interesting fact I found, maybe a reason that it's used predominantly in boat hulls and things like that, glass fibre reinforced plastic does not interfere with radar systems. How exciting is that? So there you go, some other reasons why glass fibre is such a useful material. This one is an interesting one. It's called Tungsten Carbide, and you would probably find it actually in our workshop here in school. It looks like something like an alloy. Some people might think it's an alloy, but it is actually a composite, because particles of tungsten carbide are embedded into a softer matrix of metallic cobalt, which is just a posh way of saying it's kind of a load of materials kind of squashed together. Tungsten is the heaviest engineering material, so it's got a really, really, it's very dense, it's very heavy, But the massive advantage, and the reason it is used for things like the tips on saw blades, the tips on high-speed cutting tools, things that might get very, very hot, armor-piercing shells, there we go, if you're interested in that kind of thing, I guess. It has the highest melting point of all metals, meaning that if you had a tungsten carbide drill bit or a tungsten carbide lathe tool, you are going to be able to cut materials that produce a huge amount of heat, and you know that that tool is not going to melt or change shape or break, basically. So tungsten carbide is used for industrial machinery, cutting tools, the edges of chisels, the edges of saw blades and lathe tools, because it is extremely hard, it has very high tensile strength, it's very heat resistant, and it's really good in high temperature kind of conditions. So tungsten carbide is basically a posh material used on the cutting tips of saws and drills and things like that. These two I'm going to cover quite quickly because they have come up before in previous exam papers, normally just to give a definition of them rather than talk about them in too much detail. But you could be asked about something called glulam. So glulam basically means glued and laminated pieces of timber. So you might be able to think of another material that is glued and laminated together, that being plywood, but this is not quite the same. This is actually big blocks of things like pine or hardwoods like beech and ash, actual big chunks of natural wood glued and laminated together. The reason for this is because it is glued and laminated together, it's stopping a lot of those problems with natural alternatives, such as if you just had a massive chunk of wood, it could twist, it could warp, it could naturally crack in certain areas. This stops that happening because it's got the glue between the different layers. It kind of holds it rigid. And another big advantage is it allows you to create massive, great big beams and structures from natural wood, which is a lot more aesthetically pleasing. It's really stunning and is often used in architecture, in beams, bridges, domes, arches. It's a really high quality, well finished material that looks very attractive. And it's a more natural alternative to something like concrete, which would be very, very expensive. Not very expensive, sorry, it'd be very, very heavy, and glulam is a lot lighter. So glulam is glued and laminated chunks of timber put together, stops it warping, stops it twisting and cracking, but brings all of those advantages of it being timber. It's beautiful, it's got a lovely natural grain, you can apply a finish nicely to it, and there you go, glulam. Next one, aluminium composite board. This is thin sheets of aluminium with a foam core. Some of the reasons for using this, and most of the reasons for it, are it's used in a lot of shop signage. It gives quite a nice quality finish on the front. It looks quite posh, looks high end. But also it's quite interesting that it's good for soundproofing in panels of cars, buildings and boats. So it's a lightweight material. It's lightweight, but it still gives you the look of a piece of aluminium that at that thickness would be very heavy and very expensive. So you can see the advantage there. It's rigid, it's tough, and it's got good thermal and sound insulation. So you can see some of the advantages of that material. Right, we're nearly done. This is a whole page about concrete. Did you think that this PowerPoint could get even more exciting? So concrete is a composite. Some people think they get confused about what's the difference between cement and concrete. Cement is actually a part of concrete. It's lots of basically types of stone and sand all combined together with a fluid cement that hardens over time. So it's a man-made rock basically, and it's got some really important properties. It's very strong in compression, hence why it's used in buildings to support heavy loads and bridges. It's very durable, again, why it's used in those kinds of applications. You need it to last a long time. Really good fire resistance and thermal and acoustic insulation properties. And yet again, makes it very, very suitable for things like buildings, where you want to have, you know, resistance to those kinds of things. And it's relatively good in impact resistance as well. So it's used from everything from roads to buildings to bridges. Some other applications are things like pipes and foundations, driveways. I'm not going to go through this very much. On the right hand side, you might want to pause and make a few notes. Some of the key things that stand out to me, things that you need to know about concrete are it's very cost effective. It's actually recyclable, so once it's been used, it can be broken down and used again. The strength of concrete actually increases over time as it sort of settles and hardens. It holds up against lots of different weather conditions. It doesn't burn easily, and it doesn't rot or you know, go moldy or anything like that. It's, like we said, it's fire resistant, and it gives quite a long service life. Concrete's becoming quite a fashionable product. So you can see the stool that's been made at the bottom there, which I think is absolutely amazing. It's been made from concrete. So concrete can be polished as well to get a really high quality finish. So it is a composite. It has lots of good properties, and hopefully that gives you a little quick overview. And there's a couple more things that you need to know about concrete. There are two other different types that you need to know. There's reinforced concrete, and this is basically, so the picture there is perfect to show you. Imagine almost like either metal rods or bars or a mesh that is basically put into the middle of the concrete and then covered in the concrete, so it sort of sets in the middle. And this just basically helps to resist different forces. So for example, if you had a mesh like that, that's going to be strong in lots of different directions. It could be that you put bars through to make it strong in bending or in tensile directions, so in stretching. But basically reinforced concrete just means it has steel bars or mesh or rods going through it to give it strength in different directions. And the last one, fibre cement, which I must admit I didn't know very much about, but it's basically used for roofing, and it's cement reinforced with cellulose fibres from plants, I would imagine, and it's kind of made into this kind of curvy, wavy shape. And the reason that it's used for roofing is it's very, very hard. It's really resistant to things like impact, so like hailstones and stuff are not going to damage this kind of roofing. It's non-combustible, it's not going to burn. It's very water resistant, and it's resistant to permanent water damage. It's very long lasting. It's got excellent resistance to UV. So all of the kind of properties that you would need from a roofing material. So I hope that helped. That is an overview of the composites that you need to know about. And I'm going to leave it there. So I'll see you on the next one.